This is not a test. This is not a test. Welcome, everybody, to the Talley Infinite Electronics Protecting DAS and Small Cell Networks presentation. We welcome you. We wanted to get a little bit of some housekeeping items out of the way, and we wanted to make sure that everybody is going to have a pleasant time with us, as well as an educational time. So let me first, before we get this all kicked off, cover a few things. Number one, please mute all of your phones, except for the presenters, of course, Dan and Robert. Please mute all of your phones for the audience and for yourself to make sure that we can all hear each other and what's being presented. Likewise, if you're attending the webinar and you're calling in from a separate phone, all you have to do is mute your microphone. All you have to do is mute your microphone, and then that way you'll remove any echoing effect. We've tested that, so we know that that actually does happen. So please be cognizant of that. Finally, we are going to be recording this session, but you're more than welcome to get a copy of this, but you're more than welcome to type in your questions into the chat box while you're muted as well. So mute, we are recording the session. And if you have questions, hold them to the end, and then we'll get to as many as we can. If we have a question that we can't answer in the time frame allotted, we will go ahead and respond to you afterwards and make sure that we get answers to the appropriate people. Okay, so we're going to go ahead and get started. And let me go ahead and kick this off. So I am Reese Fernandez, the Director of Training for Talley. With us and presenting today from Infinite Electronics is going to be Robert Sid and Dan Rebeck, both product managers in their own right for a specific set of products that we're going to be covering today. That would be the mute button, please. Let that one just go through real quick. Okay, thank you.
What's up, buddy? Yeah,
and then I think we got a little bit of noise. I'm going to go ahead and mute everyone for a second. All right. Hopefully that'll take care of that. Anyway, Reese Fernandez, Robert Sid, Dan Rebeck. What we're going to be covering today and what Talley offers is products for 5 different applications. The 5 applications that Talley supports are the macro cell or SMR networks, DAS and small cell, which will be the focus of today, microwave as an application as well. We also focus on industrial SCADA and mobile LMR. Each one of these applications is something that Talley services, but today's focus again with Infinite Electronics is going to be focused solely on DAS and small cell. Their products do bleed over into other applications, as you'll see. Now, DAS and small cell is the application that's pretty prevalent in today's world as coverage and capacity becomes very important for different venues. And so what we're going to do is focus on this application. But you know this as in-building coverage, small cell and small neighborhoods, as well as things like parking garages. The way that we educate through and internal to Talley is through Talley's ABCs, or our network elements. And so A being support structure, B being signal transmission, and C being power and grounding. Anything that powers up also needs a ground. And so as we break up these components based off of the application, we also want to identify which products fit where. Okay? With that said, I'd like to go ahead and turn this over to Mr. Dan Rebeck, and you, my friend, have controls as of right now, sir.
Oh boy. All right. Hey, thanks, Reese, and a big thanks to our audience for joining us today. So Robert and I will introduce solutions that Polyphaser and Transtector brands offer to power and protect your small cell and DAS deployments. That'll include Polyphaser surge protection technologies for RF, Transtector surge protection solutions for AC and data applications, and the Transtector integrated small cell cabinets. So I'm going to go ahead and hand it over to you, Robert, to get started.
All right, thanks a lot, Dan.
And again, thank you everyone for being part of the discussion here. What we're looking at is addressing, as Ray said, the small cell market. So as bandwidth and capacity starts to increase and everyone has access to smartphones, the amount of the demand for bandwidth just increases enormously. And a lot of municipalities aren't allowing for new macro sites to be deployed. So in order to address the situation is the small cells are being deployed and they're being employed in buildings, they're being deployed in certain main venues in the city, stadiums, for example, shopping malls, city squares. And so we're addressing some of the protection elements and grounding elements needed to assure that these small cell sites remain operational. And the assurance is by integrating surge protection into your small cell site, you reduce the likelihood of failure for that site, you reduce the downtime that you have for that site, and you eliminate the cost that needed to go out and replace equipment on that small cell site, which could be, be thousands of dollars a day. One of the areas that could be protected is the RF part or the wireless part of a small cell site. Typically when lightning strikes nearby, it doesn't have to be direct, it could be somewhere nearby, what's going to happen, it's going to induce currents within any cabling in the system. In the example here, we're looking at a coaxial cable, which usually feeds the wireless or RF line. And what happens is this very short, couple of microsecond pulse, electrical pulse goes down the coax. And if the wireless system is not protected, it cause major damage to the radios themselves. And some sort of phenomena occurs also on AC and data lines. So these lightning strikes, even though they're not direct, could induce currents, which can cause damage to your end equipment. And here's an example of what these pulses look like. They usually have a curve up and then kind of a slow decay down. But again, these are in the orders of, several hundreds, tens to several hundred microseconds. And even though pulses are very small, the amplitude of these surge currents could reach thousands of amps. So it's just enough to pop, an IC circuit that's up front in the radio, or maybe even some of the components in there, and cause, failure or latent failures, which are even more difficult to assess. One of the concepts behind suppressing lightning transients that really made polyphaser, so popular in the field is the fact that the concept behind filtering. And so the concept behind filtering is, if you look at the image above, I have a sine wave, and that sine wave is at a particular frequency, and I kind of mapped out that frequency on the right. And let's say it's right around 9 megahertz. Now in the circuit, if I wanted to get rid of all 9 megahertz frequencies, I can put a filter in there that prevents 9 megahertz from going through, and my sine wave would just drop to 0 because the filtering is removing that 9 megahertz frequency band in the example above. Now, if I look at a lightning transient or a lightning pulse down in the bottom left, you can see it has that rise and decay time on it. But if I look at the frequency components that make up that electrical pulse, I'll discover that most of that energy is at 1 megahertz or less. So if I'm able to create a circuit that removes 1 megahertz or less lower frequencies, I can get rid of most of the lightning energy. And so this is the strategy and concept behind a lot of the polyphaser RF arresters, is we're providing a filter, a lightning filter, to reduce the amount of lightning that can get into a wireless system. And this is a really key point, because we have different products for this application, and specifically for cellular or small cell applications, we have the SX family of RF surge arresters. So the polyphaser has a patented SX or spiral inductor technology, and what this is it's basically a lightning filter. Again, because we're trying to weed out 1 megahertz or less lower frequencies, we have a solution here in which we have a filter that's literally always on. So anytime a lightning strike or a lightning pulse emerges on your RF coaxial line, that energy is immediately shunted to ground or taken away, reducing the amount of energy that would go into your radio. And the kind of concept behind this is we have a coaxial body, and here we have these spiral inductors that go to ground. And here's the cartoon section. It's hard to see here, But if you can imagine, like on top of an electric stove, you have these sort of spiraled wires or spiral conductors. That's what we have inside the patented Polyphaser SX technology. So this particular platform is very effective at not only shunting lightning, but being able to maintain the RF integrity you need for a high-performance cellular site. So this product is designed to have very good pin performance, but also accommodate some of the newer type of coaxial connectors that are out there. One of the de facto connectors, coaxial connectors that are being used, the 4.3-10 connector. This connector incorporates the compact size that you see with an N-type connector, but it also is designed to allow for PIM that you would normally see in a 7/16" DIN connector. So by combining the best of both of these worlds, the 4.3-10 DIN connector was designed and has now been adopted by most cellular operators within the world. Because of the compact size, it reduces the loading of the cables going up the pole. It reduces the amount of size that you have overall, and it allows for a denser, more compact cell site deployment. Because the 4.3-10 is being adopted by the industry, here at Polyphaser, we designed a new arrestor, not incorporating the spiral inductor technology that we have for filtering lightning, but also the 4.3-10 connector. So this works in the cellular bands from 698 to 2.7 gigahertz. So it's ideal for co-located small cells where you'll have multiple carriers on one RF line. And also we've incorporated a very low pin rating on this product in order to allow for that co-location site. And we released 4 products total, 2 products that are DC block, in which the center conductor on the coaxial line is not intended to have any current, and we have 2 that are in the DC pass line. And this allows for AISG signals or preamplified, current going up or preamplified antennas, so that way we can either power these things up on top of the roof or on top of a mast. And so we have them in female-male or female-female genders, which comes about giving us 4 different products to use for your wireless protector. The protection is very important. This compact size incorporates protection, but one of the things that we found with small cell sites is, how do you put together an infrastructure needed to power all those radios? So here we talked about protection on the RF coaxial line. Now what we want to do is, how do we protect the rest of the radios from like the wired lines, the AC lines that go into a site? One of the things that we did at Transtector is design a new line of small cell cabinets. These cabinets are 8 inches wide, and 8 inches wide is typically the width of a utility pole or a light pole that you'd find in a municipality. The cabinet is integrated with a safe min disconnect. It incorporates Transtector's surge protection, and we designed the cabinet that it has a UL67 listing. And this listing is important because if you were to hang any type of power distribution cabinet on a pole or on a wall or in a building, you need to have it UL67 listed, so that way it can get through the permitting process that different municipalities, cities have today. The interesting thing about this cabinet is it harmonizes the power distribution in a given location. So a contract engineering firm, by just sticking with one type of power distribution cabinet, they can have an understanding of what's being put at that site. Or typically, if somebody was allowed just to go to Home Depot or Grainger and buy a cabinet, they may reconfigure this however they need to for that site. And sometimes these reconfigured cabinets get red flagged by the municipality as not being safe or not being compliant with what that cabinet was intended to do for. And so these cabinets have been locally approved by AT&T and Concord in the Dallas area for small cells. So again, it's an interesting concept, and it's an interesting solution because it incorporates a lot of functionality in such a compact cabinet. Here's an example of one of the small cell cabinets that we have, and the form factor is nearly the same for all of them, except we allowed for different branch breaker configurations in this cabinet. The cabinet's 8 inches wide, so it's not very intrusive once it's hung on a pole or on a wall, and it could be put into various locations due to this compact size. It has integrated surge, so up to 50 kiloamps of surge that protects all the radios and all the equipment that are being powered through this cabinet. The cabinet itself has a NEMA 3R, so it meets National Electric Code, and you can put up to 5 branch breakers, ranging from even 2 amps now, all the way up to 30 amps. And we designed this so there's ample workspace so a technician can get in there and get this site up and running quite quickly. And then we've designed this for a mounting bracket that could be used either on a pole by putting a cable, putting pole straps through it, or it could be bolted or screwed on to a frame as well. So the important things to consider for a small cell cabinet is, for your power distribution is, does it have the right UL listing? And this cabinet does. So this allows for it to comply to National Electric Codes, and it increases the likelihood that it will just be signed off by the municipality and won't be red tagged. The thing is, the cabinet has up to 60 amps, so this is ample enough current to power a site. Most of these radios and routers only need an amp or 2 to actually power, and we can accommodate up to 5 branch breakers, so we can power quite a bit of equipment for a single small cell site. And again, it's 8 inches wide, so it kind of hides, it recesses with the diameter of a pole that usually gets mounted on, or it's small enough that it can be put on an H-frame somewhere and not be an eyesore. And it incorporates surge protection. And again, incorporating your surge protection into your equipment gives you that assurance that the site's going to be up and running, which saves costs in the long term. With that being said, I want to hand this over to Dan. He can talk a little bit about other aspects of small cells. Dan?
Thanks very much, Robert. So yeah, we're gonna switch gears here a little bit to one of the synchronous data or twisted pair data protocols that you're likely to run across in the small cell world. So what is PoE? Well, it's Power over Ethernet. It's technology that had its infancy at the turn of the last century. It's still fun to say that. It's really become a key enabling technology for networking that allows for both power and data to be delivered to a peripheral with a single twisted pair cable. So you can see the diagram on this slide. The AC power delivery is limited to the electricity network connecting into the switch and the enabled hub, as well as powering up some PCs. But a wide range of peripheral devices are then powered by DC power, hitching a ride on the twisted pair cable. Anyone who's worked in a modern office environment has likely used a PoE phone. So I encourage you, next time you're at your desk, you may be there right now, check out your phone and you'll notice that there is no AC power cord. So in engineering, we call that magic. All right. So as we know, peripherals are demanding more and more power, and the governing IEEE standard has been updated to meet the need over the years. Just to go through some of the quick historical, original PoE standard was ratified in 2003, known as 802.3 AF, and it allowed for a pretty meager power level of 15 watts coming out from the source. And the original standard only allowed power to be applied to 2 of the 4 twisted pairs in the cable. In 2009, the amount of available power was dramatically increased to 51 watts delivered from the source, and that standard is known as IEEE 802.3 AT, and standard is also commonly referred to as PoE+. So now forward to present day, in September this year, IEEE is expected to ratify 802.3 BT, otherwise known as PoE++, and for the first time, the power delivery is going to be allowed on all 4 twisted pairs. And that came at the result of a lot of heat rise and cable bundle calculations to ensure that we don't cause any safety hazards by giving a lot more power to the loads. So that really opened the door for new power classes that will be able to deliver up to 90 watts from the source, and it paves the way for future PoE applications to emerge. So for example, when we're talking about small cell applications, it is expected that some of the new radios that are going to support the densification of 5G are expected to draw about 50 watts. So they'll be able to take advantage of this new IEEE standard. And there's also some other really interesting applications that are expected to take the leap to PoE, you'll notice that vending machines and ATMs soon will be able to throw their AC power cords to the side as well. So now I'm going to move into the solutions that Transtector offers for this application. And before I get into the products, I would like to take a quick minute to introduce some of the surge protection technologies that are commonly used in data surge protectors. First is gas discharge tube. Gas discharge tubes provide really high surge capacity as well as very low characteristic capacitance. And that makes them ideal for high-speed synchronous data applications, and particularly for the common mode surge protection between each of the signal lines and ground, where traditionally lightning and other transients are really going to cut through those lines at the same time and either raise the potential of the pair from ground or vice versa. The ground potential may actually rise above the line. The second technology that's commonly used is the silicon avalanche diode. SASDs afford very fast response times and also tight voltage clamping characteristics, and the added advantage that they're a non-degrading technology. This technology is ideal for providing metallic or line-to-line protection to suppress voltage spikes that are induced across the twisted pair, because that can happen as well. So with that said, Transtector offers several models in the DPR series for indoor protection. And they utilize these technologies either independently or in hybrid configurations. And they are developed to be compatible with PoE, PoE+, and PoE++. Additionally, all the models that are shown on this list are capable of full gigabit Ethernet throughput. So I would say from an industry point of view right now that mass adoption is with gigabit Ethernet for throughput and with PoE+ for the power over Ethernet capability. And I think we'll see that shift in mass adoption to PoE++ over the next few years. Similarly, Transtector offers several products for outdoor Ethernet PoE protection. And of course, in outdoor applications, the lightning environment is much harsher typically. In the ALPU series, which is the outdoor models, they're available in both plastic and metal enclosures. And the installer was really taken into consideration for the ease of mounting and wiring in all of these designs. All the models can be either wall mounted or pole mounted. And again, you can see that we employ the gas discharge tube technology, as well as a premium product in this line that is 100% silicon avalanche diode protection, both line to ground and line to line. All right, and finally for surge protection solutions, let's talk about the AC service. We'll never get rid of the AC service completely. For AC protection, first I'd like to introduce one more common type of technology that's employed. That's the metal oxide varistor, or MOV. MOVs afford a cost-effective means to implement very high surge capacity, also with very good voltage clamping performance. So Transtector offers a wide range of UL certified AC surge protectors in DIN rail form factor as shown here. It makes them very easy to install in panel boards, switches, cabinets, as you saw from Robert's slide. They're available in both MOV and also in the premium 100% SASD protection, modular, non-modular. You want to go with a modular product if you'd like to be able to service that down the road without having to unwire it and replace the entire unit, and also offer visual and remote status indication. And with that, I'm going to turn it back over to Robert to wrap us up.
All right, Dan, thanks. So as you can see from today's discussion is we have a lot of solutions in order to protect, wireless and wired connectivity at a small cell site. We have AC protection, AC DC data protectors, as well as the specialized RF connectors that meet the high PIM requirements that you see in small cells today. So again, if you're looking for ways of putting up a small cell site, please keep in mind that Polyphaser Transtector does have solutions out there. Please contact us to see what we can do to help you make a very effective, highly reliable small cell site. Thank you.
All right, thank you. Great presentation. We'll give you the virtual clap there, Dan and Robert, appreciate that. If any of you in the audience have any questions, please type them in the chat box. I do happen to have a couple of questions to get started here. And I'm also going to, please be cognizant again, I'm going to unmute everybody as long as there's not a bunch of external noise, because I just don't want to disconnect everybody from what the answers and questions are. So I'm going to go ahead and unmute now. The first question that I have for you gentlemen are on Dan's presentation. Are polyphaser devices considered consumable, or that they have done their job once a lightning strike happens and thus needing a replacement? Dan?
Well, I'll go ahead and answer that since I'm the product manager for Polyphaser. Typically, Polyphaser has two ratings. One is multiple strikes. So as long as the product, the lightning doesn't exceed the multiple strike threshold, and it should still run indefinitely. The thing is, you can tell that the arrestor is working because it doesn't affect your RF line at all. It's still meeting the high performance that you need. We do have a max rating. That's the maximum lightning strike that the product can take and still protect your equipment. Your equipment may no longer meet the RF requirements that are needed, or it may be operational, within the threshold. But at max strike is just kind of giving you assurance that on the next strike, it's still going to continue to protect your equipment.
Okay.
So again, we have multiple strikes. The products can take multiple strikes.
Okay. And then the second one, I'm not sure, kind of in conjunction with that, we talked about silicon avalanche, we talked about gas discharge, GDT, and then we also talked about MOV. Is there a difference in the way that we would, the way that you would engineer a certain type of product, or from a customer-facing point of view, is there a reason why you would want to select one over the other, even with the good, better, best being non-existent, if that was the case?
Hey, Reese, this is Dan. I'll go ahead and take that one. Yeah, so I think, first off, there's a lot of virtue to develop. Oh, getting a little echo there, but that's all right. To developing, either leveraging the advantages of each one of the different technologies or harnessing multiple advantages using hybrid designs. So silicon avalanche diodes are a non-degrading technology. They're a full solid state device. So for any critical applications where you need to know that the protection has full integrity as the day it left the factory, I always recommend silicon avalanche diode protection. However, even though gas discharge tubes and metal oxide varistors are degrading technologies, they're also very effective technologies for protection. And so it's really about understanding your environment, understanding the asset that you're protecting, and then choosing the product that's going to best meet that. But certainly all the different technologies have their advantages and some disadvantages. And if there's any follow-on details that I can help out with, please let me know.
Okay, so I mean, you'd be able to talk openly about what would be the best product type for the application need then, I'm sure, right?
Absolutely. I think, when we're talking about, a good example is the difference between a macro site and a small cell site. Obviously, there's, different missions. Macro sites are responsible for keeping wide area networks up and running, whereas a lot of times small cells are used for densification, and that's what we expect to see for a lot of the small cell rollouts. So it does make sense to understand, the mission statement for your deployment and to choose the protection accordingly. One of the things that I would say specifically about Power over Ethernet is that, right now we see PoE plus as the mass adoption. We do expect an evolution to PoE plus plus. If you have line of sight to your system potentially evolving to PoE plus plus down the road, then I would certainly recommend putting a surge protection solution in that supports the PoE++. And that will essentially future-proof your network and put at least one element that won't have to be adjusted or changed as the requirements for the system evolve.
Thank you. No, that's good. That's very comprehensive. Excuse me. Another question, and then we're going to wrap this up because we're almost at our timeline. Appreciate your patience, audience. Are the small cell IP67 boxes approved at any of the carriers, Verizon Maintenance Engineering Group, something like that? Or is that something you constantly work on with calling on carriers?
Yeah, so right now it's only been approved locally within the Dallas region. So right now we're kind of reaching out to the major cellular operators to get approval. I think there's an opportunity here where, as the carriers allow contract engineering firms to put together their BOM for a small cell site, here's a solution that we're offering at Transtector, this 8-inch, integrated cabinet that would allow for that. But currently, right now, we don't have a corporate-wide position with these cabinets.
Fair enough. All right, well, we're about out of time. If there's any follow-on questions before we sign off, please go ahead and type them in the chat box. I'll leave that up for a minute, and we'll go ahead and address those accordingly. We do appreciate your time, patience, and attention, everyone. So thank you very much. You have a great day. There's some contact information for you if you'd like to get some more information. Other than that, have a great day, rest of your day. Thank you, Dan. Thank you, Robert.
Thank you all.
Thank you. Thanks all.
Thanks, Reed. Thank you, everyone.